Today we will solve the problem of maximum subarray. The problem statement says that given an integer array nums, find the contiguous subarray, at least one number which has the largest sum and return its sum. Okay, we have been given a array of which is called nums, and we need to find the largest sum which could be got out of any contiguous subarray. So when we say contiguous, we know that we need the subarray, we need the elements which are not breaking, a list of elements which are together. For example, -2 and 1 is a contiguous subarray inside this big subarray, sorry, array. -2 1 -3 is a contiguous subarray. 1 -3 4 is a contiguous subarray. So we know, understand the concept of contiguous. When we say contiguous, it is the elements which are not breaking, which are together in an array. They are called a subarray. Okay, let's go through the example. We have an input. In the input we have -2 1 -3 4 -1 2 1 -5 4. Yeah, it consists of all negative and positive numbers, and the output would be 6. The maximum sum which will come will be from here, 4 -1 2 1. 4 -1 2 1. So it will give you the maximum output of 6. It also, in the explanation, it says that 4 -1 has the largest sum is equal to 6. Okay, so we have been given an array which have at least one number. We are sure about it. The follow up is, if you have figured out the big O of n solution, try coding another solution using the divide and conquer approach, which is more subtle. I will stick to doing it with we will try to reach together to the solution of big O of n, and we will see how it is optimized. Okay, first thing first, when I read this problem, the thing which comes to my mind is, let's explore all the subarrays and add them and see which one is the maximum. And this will exactly comes into my mind when I start with this problem statement. So basically what I will do is, I will simply take this array, and then I will go through all the subarrays. For example, subarrays here is -2 1. The next subarray will be -2 1 -3, and then I will iterate over these subarrays, and then I can go with -2 1 -3 and 4. And there is one, this is also a subarray, -2. So basically I will go through all the subarrays, I will add calculate them, and I will get the result. How will I do this? I will start with the first left element, and then this is my left and this is my right, and this one will be my window, where I will get the sum. And once the sum is there, I will compare it with the overall sum, and then we'll check which one is the faster. This is a brute force approach, and let's see how it goes. First start with the brute force, and we will see how we can optimize the solution. So let's have a overall max. Overall max is equal to, just initialize it to -infinity. Let's start with the for loop to iterate over the I. Let's make it left. It's more clear to say that it is left of the subarray which we are considering, and left. This is my start of the subarray. Let's make it right. which will start from the left. It will be right, and this one will be right. Okay, this is my window where I will start working. So what I will do, I already have a subarray which starts from the left and ends in the right, and then I will iterate over that, and I will start getting the sum. So I will just get one more loop, which, let's make it k, which will start from left, um, and k will be equal to right. So it will move from left to right, and this one becomes k. So this is my window which will calculate the sum of the subarray at that point. um let's start with, let make it window sum is equal to initialize it to 0 and plus nums k. After completion of this, I will check the window sum, which one is the maximum. So overall max is equal to math dot max, overall max or window sum, which one is greater. So every time I complete one subarray calculation, I will check which one is maximum, and then I will simply return at the end overall max. Yes, that's it. Let's try to run it first. Is it working fine? Okay, it gives you the result. If I just try with one, what will happen? Okay, it's going good. Yeah, it's a brute force approach. We know that the time complexity of this solution is very high. It is going to be the cubic time complexity, big O of NQ. If you try to submit this, you will get the time limit exceeded most probably. Your time limit is exceeded. If I go to the details, I will see that there are 200 cases which passed. 200, there were 202 cases. The last case which was failed is very big. Let's try to optimize this solution. How can we optimize this solution? We can see that there are 3 loops running. Let's think about this inner loop. What is happening here? I'm going from left and I'm going to right, and then I'm adding that. But we can improve here by simply storing the window sum of the previous loop, because we are trying to loop again and again. So when we are trying to add -2, 1, -3 and 4, we are actually starting from -2 to 4. But we know that in the previous loop we have already calculated -2, 1 and -3. So the innermost loop might be doing a duplicate work which we can easily avoid. Let's try to optimize it first. So we already know that window sum will have the result of the previous iteration. So I will simply move it on the top. Where are you? Yeah, just Control X. Yeah, let's try to remove this. At this point, I know that window sum which are coming have already the results of previous iteration. I will just make it nums right, and then I will check the overall max. Okay, I check the window sum and then I try to run the overall max. Let's try to run this. Okay, and let's try with our example. Okay, something is wrong here. The result is not correct. What did we do? We did the window sum, and every time we calculate the window sum, we have to check the overall max at that point. Maybe that was the reason the result was wrong. Yeah, well, that was the thing. Every time a local window sum comes, we just have to compare with overall max and then get the math.max. Should we try to submit and see? Now the complexity of this solution is less than the complexity we did the first time. That was big cubic time complexity. This is big O of n square. So try to submit it. It got accepted. Yes, pretty much okay. All the test cases are passed and we have a runtime of 224 milliseconds. Let's go back. So still we have a time complexity of big O of n square. How to make this complexity lesser? Or how to make it more linear time complexity? For this problem, to have a solution of linear time complexity, we need to reshift our idea to something which is called dynamic programming and the idea of subproblems. The idea of dynamic programming is a little bit tricky because it always takes some effort to understand how to break a bigger problem into the subproblems and what should be the result of these subproblems so that it sums up to the bigger problem solution. Let's think again about this array. Let's assume that this problem, this array has just one number. What would happen? At this point, my maximum sum will be -2. Well, good. This has just one element. What happens if I have two elements into the array? What will happen? Either can have -2 or I can have -2 plus 1 or it is 1. So let's focus on something. This solution, this one is already coming from the previous calculation. So I don't have to worry much about this. What happens? We need to focus on these two. What are the choices we have? We have two choices at this point. Either we take the current element, which is good enough for itself to make a larger sum. It means that we will start a subarray from that element, or we continue the result which is coming from the previous element, previous subproblems, and we add the current element to the previous solution, and that will give us the result. So basically these two options choices we have is we have math.max of previous solution plus nums current element maybe, or current element. Maybe it's more understandable if I take the third element into picture. Then we will be able to see a pattern here. What are the options we have? We already have these options from the top coming. And adding to this, I need to add the new element or the current element to all these solutions. Or the element itself. So I don't have to worry about these solutions. I don't worry about, because these three are already calculated in a previous sub problem. Only thing I need to know about is either what will happen if the previous answer coming have the current element added, or the current element itself have the enough to make the max of the sum in an array. So it is again the previous solution plus current or current. We can see the pattern here. We always have, at each iteration of the array, we need to think whether the current element itself is enough to make the largest sum, or it will be the part of the previous solution and it will give you the maximum sum. So let's start with the implementation and then we are more clear about it. um, let's clean it up. Overall max, let's make it I, because now there is no concept of left and right window. Let's start. Let our local max is equal to overall max. In the beginning, local max and overall max is same. Let's make it, because we know that this array have at least one number, we can easily make it nums 0, and we will start our loop from 1, and local max will be math dot sorry math dot max nums I, the element itself, or nums I plus local max. Which one is greater? And we always have to come over reassign the overall max by math dot max local max and overall max. So that's it. um yeah, it's very straightforward if we understand the concept of it. We every time we iterate through loop, we check the local max, and then we compare this local max and overall max, and whichever is greater we just reassign it to overall max, and at the end we reassign it to overall max. Let's try to run this solution. Yeah, it works. It gives the right result. Let's try to submit. It seems to be acceptable. That's it. I like this solution so much. Maybe in some time I will try to code with this another solution with the divide and conquer approach, but for now that's it. Thank